Hi everyone, thank you for joining us for this Fundamentals of Adhesion and Peel Testing. I just wanted to go over a few quick things before we get started today. This is a McMesson presentation. McMesson falls under the umbrella of the PPT group. Some of the other companies under that same umbrella include James Heel and Aluris. If you are interested in learning more about either of those companies, we do have a lot of educational content for them as well that you can find both on demand and upcoming on our events page. I also wanted to let you know about our technology lab located in Sterling, Virginia. We established this as a way to support our customers via education support, proof of concept, testing, demos. A lot of people have changed job roles or taken on new roles and responsibilities, or even expanded the type of testing that they're doing. So if you do have any needs or any thing you had questions or would like additional support on, please feel free to reach out to us. We can get you in contact with the right person. Also wanted to let you know about some support staff we have. Paul Montalto is our presenter. My name's Catherine Hawks. I'm one of the organizers. And then we have various support staff located throughout the United States, Europe, and Asia. So if you do need any assistance, we can definitely get you in contact with the right person, or no matter where you are. Last but not least, did want to let you guys know we do want to keep this interactive, but to minimize any background noise, everybody is on mute. If you did have any questions, please feel free to use the raise your hand button. I can unmute you, or you can use the questions box and type your question out, and I can read it out loud for you. We're going to be recording this webinar, so you will get a copy of the recording to the email that you registered with. So do keep an eye out for that. If you want to watch it on demand and go over anything for any additional clarity, or if you had any colleagues who were interested in attending but couldn't make it, feel free to share with them. With that, I will turn it over to Paul and we'll get started. Thanks.
Okay, thanks, Catherine. Hello and welcome, everyone. Thanks again for joining us today. My name is Paul Montalto, and I'll be presenting today's discussion on the essentials of adhesion testing using the peel strength method. Before starting, however, I'd like to reiterate what Catherine said about the many companies under the Physical Properties Testers Group umbrella. So while today's talk is about adhesion and peel strength testing, we do have many other testing solutions such as force and torque, universal testing machines for materials, textile, fabrics. We even have an expertise in food texture analysis. So I'm informing the audience of this so you don't think of us solely as a this or a that type of tester company. If you're interested, we also have an educational webinar series around the various types of applications for each of those testers. But enough of that. Now back to the subject at hand. So because adhesion testing is such a broad topic, it'll be somewhat challenging to include every type of application in this talk. We will, however, cover the important areas of adhesion testing relating to peel strength test method. There are other methods for testing adhesion, such as scrape and scratch, testing of coatings and pull-off testing using a glue dolly. But this webinar will concentrate on the peel strength testing method. So following this fundamentals discussion, you'll have a better understanding of testing adhesive properties using the peel test method, why we utilize it, who it benefits, what it when it should be performed, and how that testing is done. Okay, so today's agenda. So we'll have a general overview of peel testing. We'll talk about the role of peel testing in everyday life, the types of peel testing applications that we run across, industries that use peel testing, how is peel testing performed, Then we'll get into the types of peel testing equipment. And lastly, we'll try to sneak in a few video clips of some peel testers in action. So before we start, I'd like to have just a quick review just to get everyone on the same page. This information will help keep everything in perspective and give us a better focus going forward. So these are the few things I just wanted to cover quickly. So peel strength testing is generally used to measure the bond strength between two material surfaces that are held together, typically with an adhesive or welded seam. Peel strength itself is calculated as the average load per unit width of bond line required to separate bonded materials, where the angle of separation is defined by the application type. So as such, peel testing is one of the most important or in common ways to characterize adhesive bonds. It requires at least one adherent to be held in a tensile grip and separated from the other surface. We'll look at how that process works in just a bit. The common types of peel testing methods are T-peel, the 90-degree peel, and 180-degree peel tests. There are other types of peel tests, as I mentioned, which are more specialized, such as the climbing drum peel test, but we'll discuss these at a later webinar, hopefully early next year. But for today's session, we'll concentrate on these three main tests, T, 90-degree, and 180-degree peel tests. They are the most common because they're relatively straightforward to perform and have been adopted by many industries and industry standards such as ASTM and ISO. So they are quite popular. And lastly, test data that has been collected should be ideally be plotted on a graph that shows force versus displacement, from which that peel strength value of force per sample width can be calculated. Usually this peel strength would be expressed as newtons per millimeter width or pounds per inch width, and so on. Consistent monitoring of the data from the process informs you if manufacturing adjustments are required. So in other words, too little peel strength and the substrate might lift, causing leakage or contamination. Too much peel strength, and you might find that it affects functionality by preventing opening or operation of an object or a component. So this was a very quick review, but these were the couple of pointers that I just wanted to talk about, just to make sure that we had a good understanding as we proceed with the webinar. So the peel adhesion test is used to determine the force required to debond two components joined by an adhesive or some type of welding process. The peel strength test results, also known as bond strength, is generally represented in like newtons, so the force to debond per specimen width. Peeling tests are the practice of testing adhesion properties of a film bonded to a substrate, usually by tensile testing. The peel strength determines the adhesive strength, also called adhesive fracture toughness. Physical testing of packaging products, for example, by peeling can tell us a lot about its properties and the manufacturing process, such as sealing consistency, bonding strength, adherence ability, cohesive properties of the interface, bond durability, and other parameters. So there are two primary reasons for performing a peeling test. The first, distinguishing between acceptable and unacceptable criteria by determining the adhesive strength range, which is acceptable for a consumer or for a purpose of the adhesive. So in other words, before any production efforts begin, you should really determine the standard for what are good and what are bad peel testing values. These are also known as pass-fail criteria. And secondly, you want to assess the uniformity of the adhesion of a given type of adhesive interface, for example, pressure-sensitive tape, so that it indicates any poor adhesion between the adhesive and the adherents. So this means when you're in production, you want to be able to to pick up any of those differences or process variations in adhesive strength by routinely testing against that pass-fail criteria. So now it's very likely that you've encountered peeling of adhesive applications at some point in your life. Before these end products got to you, however, the manufacturer spent time and effort determining the optimum adhesion strength and then tested for it throughout the production process. So in medical applications, the adhesive bandage is used to cover a non-serious wound or cut in the skin. It's formed by a basic layer of plain fabric coated with an adhesive material. There are several factors that affect the performance of the adhesive bandage. According to a report in the Journal of Engineering Fibers and Fabrics, one of the most frequently reported problems is the strong engagement with the skin that causes severe pain to the patient when it's removed from the skin. The peel test is used to determine the force required to remove the bandage from the skin or tissue. Now, imagine someone's grandmother trying to open her yogurt cup or frozen meal with her frail and carpal tunnel filled hands. You want her to be able to open the package easily, but the contents need to be fresh. So quality of food upon opening is directly related to the quality of the packaging material and the strength of the seal that locks in that freshness. To ensure a quality adhesive seal in food packaging materials, the seal strength must be determined. So to determine the ideal seal strength, adhesive seals undergo various peel testing experiments. So similarly, in the construction and home improvement industries, people are opting for carpet squares and self-adhesive vinyl tiles, as well as laminate flooring because they're easy to use, quick to install, and very durable. The challenge is being able to work with that flooring product, positioning it just right before pressing it into place. But once it's in place, you want it to stay there for many, many years. So these are just a few examples to highlight the importance of getting that bonding or adhesive strength just right, and that failure is not an option. Peel testing is the process you would use to experiment with your R&D formula, and peel testing equipment can also help you monitor and maintain stability throughout the manufacturing process. Next, we'll talk about the three main types of peel tests. And again, those are the T, 90 degree, and 180 degree peel tests. As I mentioned earlier, there are others, but these are the most common and the ones that we're going to be talking about today. So the first one is the T peel test. So picture a zipped sandwich baggie, and you were to cut off the bottom, then cut it into 1 inch wide by 6 inch tall strips. You would hold and pull apart the two loose tails or peel arms to test the bonding strength. The T-peel test is a type of tensile test performed on two flexible substrates that have been bonded together and placed into peel test grips. One substrate sticks up and the other sticks down, while the bonded area sticks out horizontally so that the entire setup forms a T shape. The term flexible refers to the ability of the adherent to bend through 90 degrees without bending or cracking. T-peel testing is used in many different industries, primarily to measure the adhesive strength of flexible materials such as foils and plastic sheet, because they can be held in that T shape. T-peeling testing is not applicable to stiff or rigid materials, as they need to be flexible. The procedure is a straightforward tensile pull test at a constant speed and, in most cases, requires simple standard grips or fixtures. And finally, the average peel strength per sample width, as we've mentioned earlier, is calculated on a force versus displacement curve to define that peel strength. That reading is usually taken after the first peak reading, which occurs when the peel is first begun or initiated. So you realize when you start testing that specimen, you'll see a pop at the very beginning, which breaks the seal. And then after that, you should see the actual average peel data on that force versus displacement curve. So typical materials that perform T-peel testing are those that use leather, plastic, rubber, and soft metals such as foils to bond, weld, or otherwise seal two or more pieces together. So again, the T-peel test procedure are commonly used when both materials are similar or both are flexible. For example, to measure the peel strength of the flexible laminates. It requires both bonded substrates to be flexible enough to bend the 90 degrees without breaking. So in this, let's see if I can get this. Okay, in this test, the tails, let's see, are we running? Yes. The tails or the peel arms are unsupported. So the entire load is applied and transmitted to the bond area. So this is an example of a food wrapper, and the welded seam was being T-peel tested in a horizontal tester. And the crosshead was programmed at 200 millimeters per minute, and the specimen was held in 25 millimeter grips. And these are the typical graphs. And again, depending on how evenly the adherent or the adhesive material is coated on the test sample, you'll either see a clean linear graph or what you're sort of looking at here, which essentially is the reason why you test. This graph seems to indicate the applicator is not applying a uniform amount of glue or adhesive on this particular test sample, or the substrate wasn't properly prepared. So the next type of test is the 90-degree peel test. And again, this is very common. This test requires a fixture to determine the adhesive strength between the flexible tape and rigid substrate, such as a plate, where the plate lies horizontally with the gripped end of the tape sticking up perpendicular, while the rest is bonded to the plate, so it forms that L shape. The procedure is used to measure the peel and adhesion strength of pressure-sensitive tapes, as well as other adhesive-coated materials. Test samples are usually attached either to a sliding table or a pull wheel, and then pulled using a grip. Special fixtures are often used to run these 90-degree peel application tests. And as the image signifies, that sample must maintain a 90-degree shape from start to finish during the entire test. Again, the calculations are the same as previous, and you would have any adhesion strength test procedure, and it's again represented in force to debond per specimen width. Generally, sample requirements consist of a set of 5 specimens that are 20 millimeters wide by 200 millimeters long, or quite honestly, whatever standard that you are testing to, whether it's industry standard or in-house standard. These can be directly cut from the product or prepared under laboratory conditions. And one of the 2 glued components should be flexible enough to be bent 90 degrees without breaking. As for the test setup, the test specimen is clamped on a free-moving table. From one end of the specimen, mechanically debond or separate the 2 components, usually a distance of about 40 millimeters. The separated top component is clamped in a moving vise, which is attached to the crosshead on the tester. And lastly, the test speed is generally 300 millimeters per minute, or again, as defined by your standard. The 2 components are peeled apart by the movement of both the tester crosshead and the table. The traverse movement of a free moving table is at the same rate as the crosshead's movement going up, thus maintaining a constant 90-degree angle between those 2 components. Let's see. So as I mentioned, the applications for pressure-sensitive tapes are endless. Food, cosmetic, medical, packaging applications, just to name a few. This next video is of a peel test on a foil sealed wine glass and is conducted using a software driven force tester. The peak and average forces needed to remove the foil lid from the wine glass are measured, and the results are displayed graphically using the force measurement software on the tester. So here, the glass of wine is held in place with a fixture that's mounted to a motorized horizontal table. The gripper, which is attached to a load cell on the motorized vertical tester, firmly latches onto the foil. The table and grip move at a constant rate that's pre-programmed and controlled by the software. So notice that 90-degree angle is maintained throughout the test. And now the table and gripping head return to their respective starting positions, ready to start the next sample. And now we're going to see the same test video overlaid on top of real-time data. The initial pop or spike that you see on the left side of the graph is what I mentioned earlier when you first break that seal. And now you can see the data suggests a more uniform bonding application between the glass and foil seal, very different from the TPO video that we just saw. And again, notice that 90-degree consistency. And lastly, you'll see the force increase again as the lid is detached from the other end of the cup. And the third type of peel test is that 180-degree test. Again, a unique test, but very commonly used for pressure-sensitive tapes and flexible laminates. Test samples are usually attached to a stainless steel or glass plate and pulled using a grip. The same calculation applies, the same as for the T-peel or the 90-degree peel test, the force to debond per the width of the specimen. Additionally, the 180-degree test is like the 90-degree peel test, except that the bonded area between the tape and plate is placed vertically between the peel test grips. So while the free end of the plate is gripped by the bottom grip, the free end of the tape is gripped by the top grip, forming a tight U shape. At the end of each test, the plate is cleaned to remove any adhesive and dried, ready for reuse on the next sample. In the 180-degree peel test, a constant 180-degree angle is maintained while the two glued components are peeled apart. The average load required to separate the two over the length of the specimen is recorded and expressed again as newtons per the width of the sample. Other methods of expressing test data results include average peak, trough loads, and other customer-defined calculations. So generally, the sample requirements are a set of 5 specimens that are 20 millimeters wide and 250 millimeters long. These can be cut from the product or prepared under laboratory conditions. One of the 2 glued components should be flexible enough to be bent 180 degrees without bending. As for the test setup, the test specimen is clamped on a fixed grip. From one end of the specimen, mechanically debond or separate the 2 components 140 millimeters in length, and the separated top component is clamped in a grip or vise, which is attached to the moving crosshead. The 2 components are peeled apart by movement of the crosshead. The test speeds are generally 300 millimeters per minute, or again, as defined by internal or other industry standards. And lastly, the test method is so popular that the ASTM D3330 dictates what kind of calculations you're looking for in that test application. So that's the speed of the test, where you start the test, where the test ends, and so on. So this is what a typical ASTM D3330 test looks like. Let's see here. So This short video shows a force test stand and in software performing 180-degree peel test based on that D3330 standard. The control software can be programmed to calculate the average peel force over the required sample length and can report the force per unit width of tape. So in this setup, you can either use a stainless steel or glass plate and attach it to the base or the load cell. The key is to maintain that 180 degrees where essentially the tape or the sample peels against itself, as well as a constant crosshead speed. And once again, looking at the graph from the test results, you'll see relatively clean display that measures both peak and average forces. Essentially, the standard states that that the average peel strength needs to be calculated, and that is after the initial break or the initial peak has occurred. And this software also has visual pass-fail indicators, and the raw data can be exported for further analysis. So to a quality manager, this is something that you'd like to see in your in-house lab. All right. Okay, so as you probably could imagine, there are numerous industries with endless applications that could utilize peel and adhesion testing. So just think about all the components or raw materials that have either been glued or joined together during the manufacturing or assembly process. So the point I want to make here is that you don't want anything falling off or breaking apart, because it could be simply annoyance, or it could be a quality issue, or it could be a safety hazard. So peel testing has been proven to be one of the most reliable methods in determining the quality of an adhesive or bonded joint. Again, they measure the joint strength under the opening displacement conditions. And although it has a relatively simple test to undertake, peel testing is often a complex test to analyze, and without a peel tester, it could be very difficult to calculate that average peel strength. So far, we discussed what peel testing is, the role in sort of everyday life, failure as not being an option, the three main test types, the T, the 90, and the 180-degree peel. Now we're going to talk a little bit about how peel testing is done. So the objective of peel testing, as with all types of physical testing, is to identify and define the ideal strength. To help us identify that unknown value, we use what we call the Goldilocks rule to determine it. So what is too soft, too hard, or just right? Or from an engineer's perspective, what's too little, too much, and what quantity of adhesive or what strength is just right for the application? If the adhesive isn't applied properly and isn't strong enough, you'll find the headliner in your car looking something like this, and you'll have to re-glue it in place. Or if the seal on your breakfast cereal is too strong, it'll end up on the floor instead of in your bowl. Okay, while I may be exaggerating a little here, essentially the concept is to identify just how much force is too much, too little, and what is just right. So let's say that through experimentation, you determined the ideal peel strength of a certain new adhesive tape that you're developing is 5 newtons per 25 millimeter wide tape. So this becomes the ideal value or your internal criteria that you would test to going forward. So on the production floor, if you randomly grab a roll of tape that just came off the line, put a sample in the tester, and it peels with 5 newtons of force, then you know that your manufacturing process is within acceptable operating parameters. If, however, the peel strength is significantly higher, then your process is out of control and you're probably adding too much adhesive, which could be costly to the bottom line. Conversely, if the peel strength is too weak, then again, the manufacturing process requires adjustment. In either case, too strong or too weak, there could be negative implications if the product gets out the door. Identifying the ideal strength through trial and error experimentation then testing for it throughout the manufacturing process will help you keep your product costs in check, your brand image untarnished, and your customers satisfied and returning for more. So this is how identifying a pass-fail value or setting an internal testing standard is determined. Even if you do test to certain industry standards like ASTM or ISO, they don't always provide that pass-fail value for your specific application. So you would have to experiment with the Goldilocks rule to determine the criteria for your specific test. Now again, a testing standard or a guide like ISO and ASTM will probably explain the process of testing the samples, the environment within which you need to prepare the samples, what grips or fixtures to use, the temperature that's required to prep the samples, and so on. But if your standard doesn't provide acceptable values or limits for your application, you'll have to experiment and identify what pass-fail conditions look like, and then test for them on the production floor or in your QC lab. The next step is looking at the type of samples that needs to be tested and determine which of the 3 most common approaches will yield the most consistent and repeatable results for your application. So again, it could either be a T, 90, or 180 degree peel. So if you're a manufacturer of flexible duct tape, we'll probably recommend the 180 degree peel test. But if you make plastic yogurt cups fitted with a flexible aluminum foil lid, or K-cups for the coffee makers, we'll recommend the 90 degree peel. And if you're gluing together strips of leather for automotive seating applications, for example, we'll probably be looking at a T-peel type of test. So again, the type of product or material being tested will determine the type of testing application. And once you've determined what type of test to perform for your application, and you know the ideal adhesion strength that you're targeting, now it's time to test. So you need to select the most suitable tester type for your application. Simply peeling or pulling off that safety cover on a brand new mobile phone, or just saying, oh yeah, that feels strong enough, may work in some instances, but the field test method isn't very quantifiable or repeatable. And mechanical or analog gauges make use of springs to convert the magnitude of force being measured into a calibrated force value that is displayed by a needle position against the graduated dial indicator. This type of force gauge is durable, simple to use, easily transported, and being mechanical in nature, it doesn't require electrical power to operate. But they have a few limitations. First, while they have display results on the dial indicator as force conditions change, however, they're not capable of sampling and holding different values over time. Most devices can hold a peak value only. In addition, these tester types have various levels of human involvement, so some more than others. This means that inconsistencies are introduced into the testing process, which does not guarantee repeatable or consistent results. And even the digital force gauges, which are very accurate, are still a handheld device and introduce variability due to the human element. They too are somewhat unreliable for peel testing applications. In other words, you could take 5 different operators, have them manually perform the same peel test, and you're likely to have 5 different test results. Inconsistencies in speed and jerkiness in pulling actions are the main causes of the variability in the test data, which will be detrimental to the actual data collection process. So therefore, in most peel testing situations, you should opt for an option that eliminates as much of the guesswork and the operator error as possible. Next, we'll discuss motorized force testers. These are better options than handheld devices, which would be the use of a motorized tester, which essentially answers the question of how fast and how far to test. So one way of controlling process variation is by using a programmable motorized tester where you can attach a force gauge to the tester. This essentially eliminates the human interaction or trying to guess how far and how fast to test. So with a force gauge in place, it will detect any exerted force, measure it, and display the results, all being done in a smooth, consistent, and non-jerky manner. The how far and the how fast is then programmed into the motorized tester. For example, let's say you want to peel a tape specimen at the rate of 300 millimeters per minute for a distance of 40 millimeters. Now, this is a repeatable and accurate process as far as the how far and how fast, doing it the exact same way, as both are critical to generating repeatable results. With this setup, you'll run a test the exact same way regardless of the operator. And of course, the gauge will accurately measure the tensile force that was applied. But one drawback of using a digital force gauge, however, is its capability of only measuring and recording peak loads. So if simple repetitive testing with peak load measurement is what you're looking for, then a motorized tester is your instrument. However, the true calculation of peel strength is usually done using the average force over the distance pulled and is determined based on the width of the sample. Consequently, a simple motorized tester and force gauge even though it eliminates the human variability factors, it's not capable of making these calculations. And asking operators to manually take readings and perform calculations is less than desirable. So on to software-driven testers. So while other peel testing options exist, the option that we highly recommend for this specific application is a software-driven tester. Software-driven testers allow you to not only configure and run the test, but also perform the necessary calculations per any specific industry standard or internal standard. Additionally, you can limit the operator to pretty much positioning the specimen in and out of the fixture and pushing the start button. That's all they need to do. The software automatically calculates the adhesion strength, which again is going to be the average force per sample width, and all of that is done automatically without any guesswork. Another cool thing about software-driven testers is their versatility, in that you can program as many adhesion peel tests as you need. They capture the peel strength of your various specimen sizes, and all acquired data can be run through pass-fail filters to determine and visually indicate that each test result falls within acceptable limits. And then you also have the additional advantage of exporting the raw data, so you can create additional calculations or cataloging or creating reports and so on. In any case, a software-driven tester offers you the best opportunities for repeatable and consistent adhesion strength measurements. So these are the tools that you would usually would use in peel and adhesion test applications. So that essentially is our webinar on the essentials of peel and adhesion testing. So to recap, we reviewed what peel testing is. We discussed the importance of peel testing to determine adhesive properties. We've looked at the three most common types of peel testing. And while there are many kinds of peel testing in addition to the T, the 90, and the 180 degree, the purpose or the objective is usually the exact same regardless of the industry. And that is to identify the ideal strength, determine the pass or fail limits, and then test for it throughout the production process. And we also discussed peel testing to characterize adhesion in different industries. We then talked about how peel adhesion testing is done, namely how to determine that ideal strength using Goldilocks rule. And finally, we considered the advantages and disadvantages of the various tester types, the handheld, the digital gauge, the force gauge, the motorized force tester, and software-driven testing solutions. So that concludes today's webinar.